Welcome to our video on 10 mind-blowing science experiments you can try at home. Have you ever wondered about the invisible forces that shape our world? The way things work, the cause and effect, the science behind everyday phenomena? Today, we're going to explore the fascinating world of science right from your home. We'll dive into some simple yet mind-blowing experiments that not only demonstrate the principles of science, but also make it fun and engaging. From the unseen power of air pressure to the surprising behavior of common household items, these experiments are designed to ignite your curiosity and deepen your understanding of the world around you. So, grab your lab coat, put on your safety goggles, and let's dive into the world of science. Our first experiment is about something we all experience but seldom think about: the unseen power of air pressure. Have you ever thought about how powerful the air around us can be? We might not think about it often, but air pressure plays a significant role in our daily lives. But what exactly is air pressure? It's the force exerted by the weight of air molecules pressing down on the Earth. It's invisible and we can't feel it, but it's always there, acting on us and everything around us. Let's do a little experiment to demonstrate this unseen power. Imagine a glass of water and a piece of cardboard. When you fill the glass to the brim and cover it with the cardboard, then carefully turn it upside down, what do you think will happen? Common sense might dictate that the water should fall out, right? But that's not what happens. The cardboard stays in place and the water doesn't spill. Now you might be thinking, how is that possible? And that, my friends, is the wonder of air pressure. You see, the air pressure acting on the cardboard is greater than the weight of the water inside the glass. It pushes up on the cardboard, keeping it in place and preventing the water from spilling. Isn't that fascinating? Air pressure is more than just a cool science trick. It's a fundamental part of our world. It influences the weather, helps planes fly, and even plays a role in how we breathe. So the next time you take a breath of air, remember the invisible force that's at work all around you. Imagine if we could harness this power for our use. Think about how we could use it to lift heavy objects or propel vehicles. The potential is enormous, and the possibilities are as vast as the atmosphere itself. Seems like magic, doesn't it? But it's just the power of air pressure at work. And that's just one example of the amazing things air pressure can do. Stay tuned for more incredible science experiments that will make you appreciate the unseen power that's all around us. What do eggs and salty water have in common? You might be scratching your head at that question, but the answer lies in the fascinating concept of density. Density, in its simplest form, is how much stuff, or mass, is packed into a given volume. It's the reason why some things float and others sink. Let's imagine you're at a pool party. You see an inflatable raft and a rock of the same size. You wouldn't hesitate to lounge on the raft, but you'd think twice before trying to float on the rock. That's because the raft, although it's the same size as the rock, is less dense. Now let's bring our attention back to the humble egg. When placed in a glass of regular water, an egg will sink to the bottom. This is because the egg is denser than the plain water. It has more stuff packed into its volume than the water does. But what happens if we add salt to the water? Well, this is where things get interesting. Salt water is denser than regular water because the salt increases the mass without significantly increasing the volume. So, when we place an egg in a glass of salty water, it floats. The egg hasn't changed, but the water around it has. The egg is now less dense than the salty water, so it floats up to the top. Isn't that fascinating? We've just demonstrated a basic principle of density using an everyday item from your kitchen. It's a simple experiment, but it beautifully illustrates the concept. Next time you're cooking and you see an egg, take a moment to appreciate it. It's not just a key ingredient in your breakfast omelet, it's also a handy tool for understanding science. So next time you see an egg, remember it's not just for breakfast, it's also a great tool for understanding density. Ever wanted to write a secret message that only you could see? Well, you're in luck, because it's not just a fanciful idea from spy movies. It's absolutely possible thanks to the wonders of chemistry. You see, the world around us is a bustling stage of chemical reactions, some visible, others invisible. These reactions are processes where substances, known as reactants, transform into different substances, or products. It's like magic, but with science. Now let's dive into our experiment. We're going to use a simple household item to create our own invisible ink: a lemon. Lemons are rich in citric acid, which is going to play a key role in our experiment. First, we squeeze some lemon juice and use a cotton swab or a thin paintbrush to write a secret message on a piece of paper. The message will be invisible once the juice dries. But here's where the fun begins. We're going to use heat to trigger a chemical reaction. This heat can come from a number of sources: a hairdryer, a lamp, or even an iron. But remember, safety first. Always have an adult present while using any heat source. As we gently heat the paper, something amazing happens. The heat speeds up the oxidation process of the citric acid in the lemon juice. This oxidation turns the citric acid into a different substance that has a brownish color. And voila! Your secret message is no longer a secret. It's visible for everyone to see. So, what just happened? It's chemistry at work. The heat triggered a chemical reaction that changed the citric acid in the lemon juice. This resulted in a color change that made our invisible ink visible. Isn't it fascinating how a simple lemon can be the key to secret messages? Who knew a fruit could be so intriguing and mysterious? But that's the beauty of science. It's full of surprises and discoveries waiting to be unveiled. Chemical reactions are everywhere, even in a simple lemon juice message. So the next time you see a lemon, remember it's not just for lemonade. It's a tiny chemical lab ready to reveal its secrets. Can raisins dance? You might be surprised. Picture this: a handful of raisins, a glass of soda, and a little bit of science magic. It's a party like no other, and it's happening right in your kitchen. Before we start, let's talk about buoyancy. It's a fundamental concept in physics that explains why some things float and others sink. Essentially, buoyancy is the force that supports objects when they're submerged in a fluid, like water or air. It's all about the battle between gravity pulling down and buoyancy pushing up. Now let's bring our raisins into the picture. On their own, raisins are denser than soda, which means gravity wins the battle and they sink to the bottom of your glass. But when you add the soda into the mix, things start to get interesting. The soda is filled with carbon dioxide gas, which is what gives it that delightful fizz. When you drop the raisins into the soda, the carbon dioxide gas latches onto the wrinkles and crevices of the raisins, forming tiny bubbles. These bubbles decrease the overall density of the raisins, and buoyancy starts to win the battle against gravity. The raisins begin to rise, carrying their precious cargo of gas bubbles with them. But when they reach the surface, the bubbles pop, the raisins become denser again, and gravity pulls them back down. This cycle continues, creating the illusion of a raisin dance party. It's a mesmerizing display of basic principles of physics in action. And it's a great reminder that science isn't just something you learn in a classroom. It's happening all around us, in every moment, even in something as simple as a raisin bobbing in a glass of soda. So next time you see a box of raisins and a can of soda, remember this little science experiment. You've got the tools to create your very own dancing raisin spectacle right at home. So raisins can dance after all, with a little help from some fizzy soda. Ever wondered why your hair stands up when you slide down a plastic slide? Well, the answer is not as elusive as you might think. It's all about static electricity. Yes, the same thing that gives you a tiny shock when you touch a metal doorknob after shuffling your feet on a carpet. Now, what exactly is static electricity? In simple terms, it's the result of an imbalance between negative and positive charges in an object. These charges can build up on the surface of an object until they find a way to be released or discharged. Here's a neat way to see static electricity in action. You will need a balloon and some small pieces of paper. First, blow up the balloon. Now rub it on your hair for about 15 to 20 seconds. What you're doing here is transferring electrons from your hair to the balloon. Your hair loses electrons and becomes positively charged, while the balloon gains electrons and becomes negatively charged. Next, take the balloon near the small pieces of paper. You'll see the pieces of paper start to jump towards the balloon. Fascinating, isn't it? This is because the negatively charged balloon is attracting the positively charged pieces of paper. But why does the paper jump and not just move towards the balloon? Well, that's because of the strength of the electric field around the balloon. The closer the charges get, the stronger the electric field, and the stronger the force of attraction. This simple experiment beautifully demonstrates the magic of static electricity. It's a phenomenon that's not just confined to your hair standing up on a slide or getting a tiny shock from a doorknob. It's everywhere around us, in lightning during a storm, in the dust clinging to your TV screen, and even in the northern lights. Static electricity, it's not just a hair-raising experience, it's science in action.